integrate this again with high resolution turbidity, relate this to suspended matter as done here. For such high concentrations we need in situ CSM to calibrate turbidity, as you need the same with your turbidity sensors in water. And here, of course, we have the reason behind this is that the Port Authority has 100 million dredging costs per year due to the sediment plume goes up and down and goes always again up to the harbor of Hamburg. So to reduce this, you must do a good modeling and of the riverbed, and also the engineering must be appropriate. So to get this information, what is happening, remote sensing contributes again. This is surface turbidity concentrations. That's also the case here for another river, the Elbe, where the concentrations are even much higher. So there's Papenburg there. And to do this on pan-European scale, we are leading a European project with European partners funded by the European Commission. So in order to introduce water quality monitoring for inland waters, to harmonize the products, to improve, of course, algorithms, we already finished this project and are now in discussion with the European Commission and the European environmental agencies about how to bring this really to a pan-European service. So finally, that's the political process in Europe to agree with the member states. We see here good success because finally the status is that we currently set up already on the commercial side this production. So this is chlorophyll for alpine lakes. This is validation for chlorophyll for a small lake close to Zurich. So this is Lake Constance, this is Lake Zurich. So Zurich is here close to the Alps. So on that side here is Lake Zurich, very, very small lake, where maybe 1 kilometer width, about 1 kilometer width. So if we go here with a satellite sensor which has 300 meter resolution, that's the physical limit already, we still can retrieve chlorophyll. So you see here the black lines. The black lines is the authority measurements. The green points are all satellite measurements only from one satellite. So we have more satellites available, and the size of the points is related with the quality indicator for this pixel that we also estimate. So you see here there are some small points here, they are more above. They are related with the bad quality, and that gives us a sign that okay, this quality estimate is something that we can really integrate in the evaluation of the measurements. We did so for Lake Constance, so this is 8 years comparison between in situ and satellite. In situ is only 1 point measurement. It is integrated over the first 30 meters. Satellite is integrated over the first, so for the optical depth that it is between 5 meters approximate. This is even a smaller lake. This is for suspended matter in Bavaria. Again, we have here the black, the authority measurements only all few years. The satellite measurements we have always. So that's again suspended matter. That's the reason why for suspended matter here you see here quite low concentrations between 0 and 2, 3 typically here, and satellites follow very well than the measurements here. It's a slow range. If you go to higher ranges, so this is now we go to transnational levels. We have here Czech Republic, Germany, Austria. Here will follow France. You see here a lot of different rivers. So this is turbidity, a very turbid river in the season June to August. So when snow has melted in the Alps. So this river Inn contributes with very high load of suspended solids to this river, and this is River Danube, so one of the largest rivers in Europe. So we map the whole Danube data. So we can now, not data, the whole Danube catchment areas over 5-6 countries. So we can now balance indeed what is the contribution of all the different rivers. And what is the environment of those lakes? So you see here in the Czech Republic, very small lakes over here. Here these Bavarian lakes. And now you can estimate seasonal patterns. You see here the peaks of those alpine rivers contributing with a high suspended matter. So this is over time from January to December for 2008. This is only one satellite. This is Landsat 7. We have 2 satellites, Landsat 7 and 8 of this kind. giving us 4 records per month. Next year we will have double this rate with the Sentinel-2. We'll have more and more observations. If we relate, just as an example, the organic to the organic absorption to the scattering, then we get the organic fraction. So you see here very low organic loads of those rivers, very high organic loads of certain lakes here. And so you can now compare on pan-continental scale then these values. I think I will skip this because some agencies need chlorophyll as eutrophication, but for those small scales we cannot derive directly, but they are indirect estimators, and which work already quite well as we do so for state Baden-Württemberg. Then coming to just have a look to the different resolutions again, it become two rivers. So this is River Mekong. You see here 2 images. One is a 30-meter product of the same day, or half an hour difference time. This is 500-meter resolution. And you see here, if you zoom into this in 500-meter resolution, this river has only a few pixels. You see there are some pixels which are obviously wrong, so this is mixed pixels and already this may be a bridge ships or with the shoreline. Still, this 500-meter resolution contains information, because if you combine this with the quality estimates for each pixels and have or integrate all these many measurements, you can derive here yearly seasonal values. So the black line in this case is not in situ, the black line is satellite derived. This is a 500-meter product at this point that I showed you before. It's close to Kanto. So in the Mekong Delta, you see here over the years the time series. The blue, the red points here in these 2 years are all in situ measures of 3 different agencies and research institutes. So it comes already quite close to those values, or follows exactly the same seasonal trends. And then the blue and green colors are other high-resolution satellite imagery, but these are then not media for a certain month. These are just the values at that time. So of course, difference in the variability is slightly higher, but they follow, of course, the same seasonal trends. So if you want to estimate the impact on long temporal scale, you can use it too, because it's a harmonized product. That can be used, for example, if you want to estimate the impact of dams on a long term. So if you go back in the Mekong Delta, for example, to the many dams that are built up here in the different countries, and for Mekong River Commission, it's challenging, of course, to get a harmonized product over the different countries and information. So to measure what was the impact of dam A, B, C, you can go and go back now up to 30 years with the satellite measurement and retrieve water quality. So this is the Chiawan Dam. This is before the closer dam is located at here where you find this small circle. And this is in the year of the closer, so that's now during this year you see the dam is filled up, concentration decreases. That doesn't mean that this is a dam, it may be just a seasonal cycle. So we may have to look, because it's again the same. So we have to look over the past, this is the past 10 years. So you saw we had here only one satellite, so we have only a few records per year at that time. You see here the strong seasonal ups and downs due to the natural conditions. And here in 2009 was a closure. Up to 2009 we had a lot of variability. From 2009 there's almost no more variability in the humidity after the dump. So we took a virtual station from the satellite after the dump. We see, of course, there's another trend. It is already decreasing independent of the dump. But there are other impacts further upstream, other dumps also, further dumps. So finally you have to estimate the full time and spatial information going to the back here to evaluate all these different information.